So you know about OOPS, right? You OOPS in any other language, either you are working with C, Java, or in any other language. So here in Python also, similarly, if you talk about object-oriented programming, then this is a fundamental concept in Python, which empowers developers to build a modular, maintainable, and scalable application. Because only writing the code is not enough. How we are writing the code, that matters. It should be readable, it should be modular, it should be maintainable, because today you are working with the project, maybe tomorrow you are doing handover to someone else and they are going to work with the same project. So they should be good to understand your project. If uh, uh, if you are only, let's say you are not doing handover to someone else, you are the one who worked on a project for a year, and next year you are going with the next assignment, and that code is already completed, it is running. Tomorrow there can be some error or maybe some enhancement required in the same application. In that case, you are going to maintain that as well. It should be good to maintain. You should write in a way, kind of generic way, or configure with config structures where if some enhancements are coming or some additional uh, concepts or maybe some errors or anything, any changes can be there. In that case, you are good to make that changes without impacting the existing flow. So we should be writing the code in that way. So by understanding the core concept, whatever we have like class age, object, inheritance, encapsulation, polymorphism, and abstraction, those are the main parts of OOPS. We can go with that. So in OOPS concept, let me go to the next slide. Here, if you see, this is object-oriented programming, which empowers to build a modular, maintainable, and scalable application. And core concept we have like class age, objects, inheritance, encapsulation, polymorphism, and abstraction. If you look at the word-wise, it's completely like Java and other programming language. Okay, and if you relate it with the real-time representation, then you will be good to develop your application. So here, if you see this Python OOPS concept, so we have these things, these points, and then if we talk about the very first one, what is class in Python, then most probably you already know what is class in Python. We are going to create a class, and then using that class you are going to work. So this is a blueprint of creating objects where we have attributes, variables, method, functions, and calling them. Functions inside functions means all the flow will be inside the class. Where this can be example where you are having a class, and inside the class you have something to call that. So let me create one class here. I am at the right place. Yes. So it was employee, right? If you see, this is employee and something you can give here. So you can define some function. Okay. Then you can have anything can be. Let's say return is 0. I'm not doing anything. So simply, then you are having one init function. Then finally you can have your main method and you can call this. So these are the class we create, and inside classes we can have multiple things. Then we have objects. Objects in the sense you have okay. Before moving to here, I had given here self. You people understand about self? Okay, no issue. We will come to this. Let's discuss about the objects. So here objects are the instance of the classes within with their own data, where we can have multiple things like we have attributes, we have methods, we have unique references. Like here you have employee one, there can be one employee and it can have some data, then you are printing the employee data, then you are accessing instance attribute. Okay, so you are providing the attribute, and then you are calling that attribute. Then you have a self parameter. Here, if I talk about this, you have this self parameter, right? So self parameter is a reference to the current instance of the class, and it allow us to access the attributes and methods of the objects. Like let's say here you have this one, then print self dot name, and so, like here, if you have this employee class, then self dot name, self dot id, self dot location, you can call with that. So it will be referring to the attribute which is calling to that method. Okay. Similarly, we have init. So init method is the constructor in Python. That is kind of initialization, you can say initializer, which automatically called when a new object is created, and it initializes the attributes of the class. So these two things are there, init and self. You will be seeing most usage in the Python. You can use that based upon your choice. If you talk about me, then I always avoid using self and init. I do not like this because I like to have a clean and clean code and all, calling the things directly either with the config or parameter properties files and all, instead of calling from this self and init. But again, this is very useful and it is really good. It completely depends upon the developers, how you would like to develop your code, how you like to maintain your applications and all. So this is the special method used for initialization, and this self it is for instance which kind of is, you can say, instance attributes initialized inside the constructor. Okay. Then we have Python objects. Then we have self parameters. Same. So it refers to the current instance of the class. For example, you have employee and a def grade. Here you are giving self. That means you are having a parameter that is the self. Now you are not giving any specific one. Now whenever you are calling this function using self, you can call. So self dot name. So if you are providing any name, either maybe that has been already implemented with a variable or directly we are providing, it will call that, it will refer that, okay, you are talking about the self, so it will refer the same. Then you have init. So init is a constructor which automatically called during the object creation whenever you are creating any of the object, and init for initialization, you can say shortcut, where you are creating a function in it. Then you are calling a self, and after self you are having a name and employee ID, some naming parameters as well. Where self dot name can be anything, and then self dot employee ID, self dot whatever you have the parameters to be called, you can do that. Fine. And then we have class and instance variable. We create the classes, we create the functions we can use for the uh, development flexibility with self and init, where with classes and instance variables, where if you talk about variables, then it can be shared across all the instances, and instance variable will be unique to each of the object. There can be two things. Like let's say this is a class, employee class, where company equal to some company name. Then definite, you are giving self name and then self name equal to name. Here employee one, there is one name, employee two, there is a name, and again employee company, there is one of the company name, and you are going to print that. So you can create either with so here if you say this is the company, this is the class. So this is the class level variable, right? Company. If you have four functions, different functions, what do you think? This will be reachable to all or not? This company value. Hmm? Why silent? My question is, here let's say you are saying company equal to something, and you have here test also. Inside test only, let's say. org name equal to company. Company means this one. What do you think? This will be accessible or not?
Yes, because
Yes,
it's a global variable.
we have to global variable.
Okay, let's
If
try
it's
this.
inside a class, I think all the functions inside the class should able to access it.
Right. So if anything you are defining before means the class level variable, and then you will be having the function level variables, right? So let's say you are having something here. You are saying to me, I, I have directly copied paste from the slide. So there is some issue. In Python, indent error is the most error. Okay, we'll check it. So if you are giving anything, let's say ID equal to 123, whatever, 123. So anything which you are taking here, let's say you are going with the ID. So here ID, okay, no, this is calling for the object. This is not taking the same. Again, it is asking for the self. Okay, check it later. So if you anything we are defining here outside of the classes, that will be available to the entire class. And then here we can have our main function, main method, and inside main we can call the complete object. Fine. Then we have, so if we talk about the class variable, then class variable shared by all the instances of the class. And if we talk about instance variable, then instance variable which is defined inside any of the function. Let's say here you are giving some name and employee ID or whatever, then that will be unique to each instance. It will not be accessible if you are something defining inside any of the function, then that things will not be accessible to the different one. Then we have a Python inheritance. You have idea about inheritance, right? Anyone?
Yes, basically uh, uh, to inherit the properties of a class, something like that. Yeah.
That is not much shortcut.
So inheritance, if suppose we already defined a function, and I think if we use that function in another class, then for the existing function, those function that was defined can be used with the other classes also, something like that. We inherit those properties, something.
Mhm. Okay. Okay. Now, mm, so inheritance means simply you have, let's say you today you are defined implementing one of the means you have developed one of the project. That project is doing something. Let's say your project reads the JSON data. It does the transformation dynamically, and it is converting that data to a normal simple CSV file with flattened schema. Uh, uh, with the there is no nested data and all. Finally, if I have to do the same, I can use your application, right? Means I can simply call your class, whatever you have developed. That means in inheritance, we are reusing. There is already some properties available, some classes, functions, methods are available. We are going to get some functionality from that specific one, either the entire 100% functionality or maybe some little bit. Maybe you have developed some class, some project, there is some 10 plus functions are there or 10 plus classes are there. Out of 10, in some of the scenario, maybe I need 10 out of 10, then I can inherit the 100% complete project I can scan. Or maybe I need only the function you used for reading the JSON and flattening the JSON, only two, but not all, because you are converting to CSV, and maybe I am trying to convert into some other formats. In that case, I do not need that part of code from your application. So I will be inheriting only two functions, whatever I need. So either we can go for the complete or you can go for the limited one with the selective. So inheritance allow one class to inherit properties from another, where you can have single, you can have multi-level inheritance, and you can have multiple inheritance. Like you have a class is having, this is the parameter you are calling. Then what is the role? Here we are giving the self, and then some project detail, whatever you have. So if simply we can say inheritance allow a class means child class. There can be a parent class and then there can be a child class. From parent class, we can inherit some properties to child class to acquire properties and methods of another class, and it supports hierarchical classification and promotes the code reuse. The code reusability is the main major thing here. If you talk about single inheritance, then a child class inherits from a single class. If you talk about this, if I talk about multiple inheritance, then a child class inherits from one uh, one or more than one class, means simply more than one parent class. And multi-level inheritance, a child class inherits from a parent class which in turn inherits from another class. That means you are inheriting from class A and class A is inheriting something class ABC, means there is a hierarchy. A is a, let's say you are working with the C is inheriting from the B is inheriting from the A. That means there is a level. Then hierarchical inheritance. Hierarchical inheritance where multiple child classes inherit from a single. Okay, here I can add one. Hierarchical inheritance. Hierarchical inheritance. And then we have one more, hybrid inheritance. Inheritance. So if you see about this hierarchical one, then multiple child which are inheriting the property from the single class, and hybrid inheritance where a combination of two or more types of inheritance. So there can be. Then you can have something. I believe that you are understanding this. Let's say you have employee class. This is the, let's say let's talk about, this is the class employee. Then you can have one class employee 2. Let's assume that this is a different class file and not the single Python file. I am taking in the single Python file. This is employee 3. Here you can have a function, let's say def employee data something. Then here you have something, let's say return 0. I'm not doing anything. If you want in employee 3, if you want to use this employee data, then we can take this, right? So like that, this employee data you can call from the employee 2. Inside employee 1 there is some function that you want to call into employee 3. So we can call function from one class to another class that will be coming into inheritance. Then we have polymorphism. In polymorphism, it is this concept is also a bit different, where it allows methods to, let me go to that. If you talk about polymorphism, then this is the same method name with a different behavior. let's say you are having either in the same class or maybe in the different classes, you can have a function with the same name, but both functions are doing bit different things. So it allows methods to have the same name but different behavior based on the object context. It can be achieved through method overriding and overloading. Overriding is something different and overloading is something different. Anyone is having understanding about that? Anyone is from programming background? No? That means you did not understood about this also, right? This inheritance.
I think something basically will define with the same name, and if we don't know what parameter to pass, we can declare it as a self, and we can use it as per our need, something like that.
You are talking about polymorphism, right?
Yes.
Yeah, so in polymorphism, the name will be same, but either we can use with the same or we can override that.
So
So,
basically,
hmm,
when we will be calling that, we have to mention the class name to use that property, something like that.
right. So in polymorphism, we have two types. One is compile time, one is runtime. If you talk about compile time, then that is determined during the compilation of the project program, and it allows methods or operators within the with the same name to behave differently based on their input parameters or use. And this is called overloading. Based upon your use case, you can change the value as well. So based upon the input parameters or use, it will be behave differently. Another one is runtime polymorphism that we say overriding. So overriding this means this is determined during the execution of the program. First one is coming at the runtime compilation. This is for the runtime, and it occurs when subclass provides a specific implementation for a method already defined in the parent class. If you have already definition in the parent class, then commonly then you can use that, and it comes as overriding. Let's say here, if we say you have a class developer, inside developers there is an employee parameter and you are calling with the self. Whatever you have, you can define your code, you can print whatever. Then you have another class tester. Again, you are talking about the employee and role is self. Here you can have something, here you can have something. Means implementation can get changes, right? So if you are doing that changes, that means you are hiding the previous one, whatever it was already, and you are going with the new definition. So you can do that. So if we talk about runtime polymorphism, that means overriding, then it demonstrates using method overriding, where you can change the value, and uh, compile time one, which anyways Python. If we talk about Python, this is not the Java, right? So in Java, C and all, programming is bit in different nature. Concept is same internally, but when it is coming to hands-on practical, it will be a bit different. So Python does not natively support method overloading. And instead of this, we use a single method with the default args to handle varying numbers of parameters you can have. And the different behaviors, if you want to add the different behaviors, then adding 2 or 3 numbers are achieved based on how the method is called. You can have some different uh, numbers for the even parameter also you can talk about, or maybe you can have the different functions where you can implement in the different way. So Python wise directly it is not natively supporting, but again if you want to implement with the same design, of course you can, because this is object oriented. This is very much flexible. You can design in your own way. You can do that. Then we have encapsulation. This is again part of Europe's concept. Encapsulation means restricting access to certain class attributes, where uh, you can simply say, if I talk about with the Java and all, encapsulation is the bundling of data. Data means attributes, and the methods. Methods means your functions within a class, restricting access to some components to control interactions. If you want to have some controlling, some access related, Then you can go for this. A class where we can say a class is an example of encapsulation, as it encapsulates all the data that it's a member, function, variable, everything. You can define a class. Inside the class you can have each and everything, and then you can think about either that should be accessible by anyone else or not. Let's say you have two classes. One is financial data, one is commercial data. Means one class is managing for the commercial, one class is managing for the financial. Now a third person is there. That third person want to access whatever you have implemented. If you would think that okay, I would like to give access for commercial but not the financial one, you want to restrict that. Of course you can. That person will not be able to inherit that. If you are making that public, they will be able to inherit. So whenever you create the class, inside the class you can have everything. You can bind each and everything. Next is the step for the accessing, how it will getting access. Then you can have public member, you can have protected members, and you can have private members. You can have up three types. Public members means accessible from anywhere. If you create a class public, then anyone can access that class. Even I can do some inheritance, I can use that, I can call that. Protected member. Protected member means if any class I have implemented with the protected, then it will be accessible within the class and its a subclass. Like I have class A, then subclass B, subclass C. Then whatever I have defined in the class A, it will be accessible to class B and class C because they are the subclass of the main class, but not outside of this. And then private members. Private members means if I define anything inside a class, let's say class employee, then that will be accessible within this class itself, not inside any other class. If any, this is employee, there is some other class organization. Inside organization, I want to inherit this employee, I can inherit, but if anything is defined as private, I would not be able to access that because that is defined as a private. So private means that will be accessible only within that particular class and not out of the class. So this is about that. And then you have, you get it or not? Sorry?
Got it.
Okay. Anyways, if you do not get it, just let me know. So simply you can say public members easily accessible and protected members. It will be accessible only with the class and it's a subclass, and private members it will be accessible only within the class. But in Java, if you anyone has it, then you have keyword public, private, and protected, right? There you can say public, and then you can say your variable name, whatever. Let's say test equal to something. Then it you can define okay, this is public or this is private. But what how you are going to do that in Python? So you have some different things. Let's say you are saying I am going to define a function. Oh, let me say this is employee, right? So I will go with the same. This is employee class. Class employee. I have one definition, and let's say the name and age. Name, age, and location. Not name, age. Let's say department. Department and location. Location. I have three. Then I'm saying self.name equal to name. This is public. Public access or public attribute, let's say. Public attribute. Then you can have self dot department. Department equal to, let's say IT. Or simply say department. Later we can initialize this. Then if I say department, then I can have it with underscore. Okay, underscore department, then it will be protected. Protected attribute. And then we can have the private one. So for private one, you can say self dot location equal to double underscore location. I think I gave it wrongly. This should be like this, and it should be this. That is why this is failing, because I am going to define here, and this will be private attribute. Okay, so if you in Java and all, you have a keyword public, private, protected. Here in Python you do not have, you have global keyword is here. Okay, but like that, if you want to make it accessible either within the class or anywhere or within the subclass only, then you can do like that. If you do dot name, then it is public attribute, anywhere it will be accessible. If you are saying underscore one underscore, then it is the protected one. It will be accessible only with the class and with the child class subclasses. And location, that is completely private, it will not be accessible anywhere outside of the class. Okay, so like this we can have. Then we have next one. I hope this is clear. And then we have abstraction. Abstraction means hiding implementation details. Okay, so if you have some implementation and you do not want to public that, you want to hide that, in that case you can go for the abstraction. So abstraction hides the internal implementation while exposing only the necessary functionality, and it helps to focus on what to do rather than how to do. Because how to do is already there, what to do you have to think. Then there are again types of abstraction like the previous one, where you have partial abstraction or full abstraction. Partial abstraction, where abstract class contains both abstract and concrete functions, concrete methods, and full abstraction means abstract class contains only abstract methods like the interfaces. Okay, where you can go with that. And how you can do that, let's say you have a, here we have created some classes. Here you have, let's say I have this employee class. Okay, I will delete all these things. This is kind of rough. I will take this employee class only and I will comment it out. Then I can create one more class, employee employee one or employee new something. Employee new, where you can say from employee, you have employee class. From employee import something. What is there? You have some init function. Let's say I am defining some def test, some function, something print test function. Okay, so this is the test. Here you can say import test. Then you can have abstract methods as well. Let's say if you have defined, there are some abstract methods. When you are doing the exercises, you can take care of it. Methods. Then let's say you are creating a class test, employee test, and you are let's say this test you have taken from that class, and here you are taking again test. You are calling the same. Then you can, this is the abstract class. If you are creating like this, because you have this class name and here you need something that is the test and that is coming from this employee class. Maybe that is fully implemented or partially implemented. It depends. Then let's say again you are having one definition. Simply I'm taking that in it only. I don't focus on the syntax because here it is not going to be correct. Again, indents are wrong. Okay, simply because simply I'm typing. So here I can have self. Let's say I'm taking self and I'm taking some name. And then I'm saying self dot name equal to name. Simple. And then I can have some abstract method. Then I can have abstract method. And then I can say def or department. Let's say something I want to define. And it says self parameter here as well. And here, let's assume that this is your abstract function. Okay, abstract method. You have to define it. And then you are doing something and then finally you are saying pass. Pass means this is your exception handling. You can take it how you want to pass or you want to break or you want to go ahead. Then you can have, so this will be kind of your abstract method. You can have some concrete method as well. Concrete method in the sense, let's say you are having def and you are saying location. Inside location you have, let's say, self, and you are defining something inside this. So you can say, let's say this is your concrete one, concrete function, concrete method. Okay, then you can have some partial abstraction. Inside partial abstraction, let's say again you have some another classes, another function. Let me copy paste it, and you are going with location one. So inside location one, you can say, okay, you can say here some print something test. So you are giving something partially. Okay, I will delete it. Otherwise it will be wrong. So that can be partial abstraction. There can be some either you are implementing completely or you are calling the concrete method or you are implementing with the abstract one and then you are calling. So you can create either you can implement completely or you can have the partial one, and then you can go, if you are going for the abstract method you can take it and then you can go with the development. So partial abstraction where class H will be having its own functions. And why we use it mostly abstraction? Because abstraction ensures consistency in derived classes by enforcing the implementation of the abstract methods, whatever is already defined. Okay. So here we can hiding the complex implementation details and providing the simplified interface. Let's say you have a one abstract function and you have did something. I want to use that function, same function, but maybe whatever complexity is there, we can go with the hiding that, and we can provide the simple interface for the same, and we can use that simple one. So like that, mostly here in the OOPS, if we talk about the Python, we have four parts. When there is encapsulation, we are building data. Data means attributes and functions that operates on the data with the single unit. Single unit in the sense class means binding each and everything, your data unit, your data functions, variables and all inside the class. That is the encapsulation, binding all together. Abstraction, where we can have some abstract functions, we can have either partial or fully, like including concrete and all, where we can hide complex implementation details and provide the simple interface whenever we are calling that. We can have inheritance where either in a single class or a multiple class with single level or a multi-level inheritance we can do. We can reuse the code with some another classes. And then polymorphism, where you can have a single interface uh, to represent the different data types and objects. Again, accessible parts and all, as I said, you can have private, public, and protected to make sure that who can access your data and what can be the level of accessing, because maybe you have some confidential data functions and all. You do not want anyone to access that, then simply you can restrict. Okay, then the one question can be there because people ask, right, about object oriented programming, like Java is object oriented or not, Scala is object oriented or not. Simply there can be a question. Even Python is 100% object oriented or not. Anyone can answer this?
I think it's object oriented because we have all the mechanism of object oriented programming in Python. Maybe
Yeah.
syntax is different, but we are using
Yes.
in that, so it's object oriented.
Correct. So Python is a multi-paradigm programming language, right? That means it supports multiple programming, including procedural, functional, object-oriented programming. That is really means it is supporting everything. And Python, it is completely object-oriented. It also allow procedural and functional programming styles, functional programming like Scala and all. So we can say yes. Then another question you may get frequently with the Python about init and self. What is self parameter and what is init and when we use it. So you can simply say about init if we talk about this underscore init, again underscore, this is right. So init is a special method, we can say constructor in the Python classes, and it's automatically called when a new instance in the sense object of the class is created. Its primary purpose is to initialize the object's attributes or perform any setup requires for the class. Like here you are going for the init function, then you are giving yourself, then args1, then args2. You can have multiple args and you can call that like self dot name, self dot you can have args2, args3 and all. And then you can self again you can explain that. Then there is one more keyword super. Okay. So there can be sometimes maybe you can get what is super in Python. So super is used to call method of a super class. Super class means parent class, which we are talking about inheritance. Inheritance you can have class A, class B, class C, and they are calling each other. Means inheriting the functionality. So super is used to call methods of a super class and from a subclass. Means you have a child class. Let's say you have class A, class class A and another you have class B. So you want to call functionalities from class A to class B. Class B can be the child class, it can be treated, and A can be treated as parent class in this case. So it returns a proxy object that delegates a method's calls to the superclass. And this is useful for accessing inherited method that have been overridden in the class. Like here you have a init, right? So with init, let me define one function. Let's say I have a class, child class. Simply for understanding, I'm taking this child class. Let's assume that we have a parent class, and here I am calling parent class. Parent class. And then I am having a definition def init and self and then let's say args1 and then args2. It can be anything. Args2. You have two args. Now we want to call from the parent class. Just give me 1 minute. Okay, so here we were talking about this super, right? So where you have a child class, then you are calling the parent class, and here you are going with the multiple args. Then if you want to call this, you can have this keyword super. So it says super, and then dot. You can say your init and args1. You can call this. And if you are doing this, if you are calling like this, then this is the method of parent class. This init, you can assume that this is the parent class function. Or let's assume that this parent init. Simply let me name it parent init, and I will remove this or parent function. This is parent function. Okay. It means this class, this function is available there. So this function of the parent class where you can say self dot args2, where you have args1, args2. So how you are going to call this args2? So either you can call from the same class. So this init is of the child class because you are defining here, and you can have some init function or maybe some naming function in your parent class. That parents class you are calling, where you are getting self.args1 or args2. You can call out from there like that. Using super we can call. So super is used to call methods of a super class in the sense parent class from a child class, and it returns a proxy object that delegates methods to the super class. And this is mostly useful whenever we are accessing the inherited methods that have been overridden in the child classes and all. Then you can have another question in Python. In Python, if anyone is talking about, if you have experience with Python, then these questions are there which can be raised. So next question can be related to self. What is self? So self is a convention in Python used to refer the instance of a class in the sense object itself. It's the first parameter of instance and refer to the object calling the method. If you are going for the self, that will be always with the first. You can't say here self. Okay, that will not work out. If you remove from here, that is not going to work. Then if you see the color wise also in Python, that you will be getting the changes. So now this self will be taking as a self parameter and not at the self what we are talking about. So this will be the first parameter of the method and refers to the object calling the method, and it allow methods to access and manipulate attribute in the sense variable that belong to the instance. Okay, then this is about oops in Python, and here you can go through this four pillars of the oops. Then what is oops, what is self, what is init. You can do something. Then we have exception handling. This is the major part. Whenever you write the code, doesn't matter what you are writing, how you are writing, but either you are handling properly or not, because some error can be there and that error should be handled properly. If you are not handling, then maybe at the runtime or at the compile time you may get face that, and again if you are not facing, then maybe that can be something there is something wrong but you are missing that. So sometimes it can be the corner cases, and you can have some bigger issues, bigger challenges. So two things are there. One is exception handling and one is error. Okay, error and exceptions are different things. Error means what? Anyone can define what is error and what is exception? Simply single line. No. Okay, error means simply here if I am going to this class and I'm saying one name equal to, you know that our variable name can't be start with an integer number, right? Any number. So this is just syntax error, or this is the I'm saying name equal to Anamika. I'm giving this Anamika, but I am missing this. So this is syntax error, right? So this is the error. So in Python, if let me go here. First, let's talk about this exception handling. So this is the mechanism to manage runtime errors in Python, and it ensures program stability and user-friendly error handling. It is important because it prevents program crashes. Let's say you did all the development and for small things it can get crash. It simplifies debugging and improves the code readability. Then you have exception. Exception in the sense n equal to 10, then try. You are saying this result equal to n divided by 0, then 0 division error. Except if you are trying good, you are trying this. If not, this is not happening, then what you want to handle? You want to handle 0 division error, and you can print can't divide by 0. So you are handling this error. Output will be can't divide by 0 because this is going to try this, but this is not good. This is not able to happen. Then this is moving to this except block, and this is returning this error. Where if we come to this, we are going to look into this error and exceptions, then try, except, else, and finally blocks. Then some common exception, and then catching and raising the exception, including advantage and disadvantage. Go to the first one. What is errors and what is exception? Errors, just I show you. If you are doing something, you are missing something like logical errors or syntax errors. These are the errors, but these are the serious issues. Serious issues in the sense everything is fine. For small mistakes, everything can be crashed. It occurs at compile time or runtime, preventing program execution. And example wise, you can say missing parentheses in a print statement or syntax error or indent. Even in Python, indent error also matters, right? Let's say this is here, this is something. If I do something like this with this one, then again this is going to fail because of indent. Right now, maybe I will not get, but later it will be failing because indent is not same. So indent also matters in the Python. We have to take care of that. And when we talk about exception, then this is manageable condition during program execution. We can go through the implementation and we can talk about, okay, do this try. And if this is not happening, then let's catch the exception. And there can be several kind of exceptions. Let's say you are reading the file, then file not found exception can be there. You are dealing with the numbers, then there can be something else. You are dealing with list and arrays and all, then out of array, out of some index, right? So multiple can be, you have to handle that. So manageable conditions during program execution, and it occurs at runtime, and it will be disrupting the program flow. Example wise, value error, zero division error, file not found, invalid user input, something can be. Like here, if we say this, let me run this. Anyways, I'm going to delete all the things because this is kind of rough. And let me run this. This is coming with the zero division error. Okay. And zero division error, division by zero. Okay. So this is going to fail. And this will be having again error with the type error, this second one, because we are going to do the plus string plus integer. That is not possible. Even we can do concatenation, but we can't do sum. Then here is syntax error. like I am missing the parenthesis, then of course this will be failing. And so this is called error if we talk about this one. So this is the difference between error and exception if this question is coming to you. So here we are missing the parenthesis. If you are running this, then you are going to face the issue. Anyways, I will comment the above one. And let's go with this. Then exception n equal to 10, and then you are trying to make it divide. Let me take it down. Otherwise, this will also fail. Let's run this. First, this is failing it for the compilation itself. This is saying this was missing. Even that is the second one. This should run first, right? This exception one. But because of this parenthesis, this is the error. Exception will be coming at the later point. Exception will be coming once all the errors are resolved. So this is the next part of the exception, but itself as this is the next part, but again this is failing at the first because it our program will be taking care for the errors first. It will be trying to resolve that, and once that is resolved, then only this will be reaching to the next point, and that can be some exception or maybe some other initialization. Then you have try, catch, else, and finally. These are the blocks in any of the function. This is suggested that whenever you are defining any of the class, you can go with the simple one, but it is good if you are going for all the things properly. You can increase the readability and then maintainability, and again you will be good to debug the code. If any failure and all, you will be good to get what is the actual issue. Then you have try, code that might raise an exception. You don't know, there can be, so you can go with the try block. Then except if try doesn't happen, doesn't work properly, then what is the thing you want to handle? Then you can handle a specific exception. If you are not sure about the exception, then you can go with the default one. Whatever error is coming, just capture that. Then you can have else. If then what you wanted to execute if no exception occurs. And then finally means whatever happens, let it be, but finally I want to execute this. Then you can go for the finally block. Let me copy this and I will run here. What is this? Copying paste means another issue. Okay, there is an indent error. Okay, so like here you have try, then after try it is coming with your result, then you are going with the except. So first try this num, there you are entering a number, whatever number it is you are going to divide. Then except you are going with this zero division error, cannot divide, else you are going for the last option, and finally you want to do something, so you can have the finally block. Okay, so like this let's say you are saying try, and inside try you are giving num, then result. Let's take this result, and then you have accept. Inside accept you have print, and then you have else. Inside else you have print, and inside finally you have this again print. Let's run this. Enter a number. Let me take it 5. Then result 2.0, execution complete. And if I run again, let's take it 1 itself. then execution complete, whatever. Then this is coming with this. And if I say 10, just I'm trying with something. Okay, this is taking care of it. Fine. So like this, you can have your try, then you can have accept if that is not divisible. Let's say if this was 0. Then again, this is taking something wrong. Okay, can't divide by 0. So now this is coming here in this except, and it is coming to the except block, but again this is going to finally as well. Finally, whatever you want to do, you can implement here, and even in case of error exception also, your execution will be completed with that block of code. So you can take care of that. Then you have next one, common exception. There can be some common exception like value error, key error, index error, type error, and zero division error. Okay, like this is the list, and inside this, from this list, if you want to run from this one, let me take it, and then print and accept this one. So if I run this, okay, this is again running with this exception list index out of range, because this is talking about 5 and there is no 5, right? There is 0 1 2 like this, so it will be failing. So there can be several exception, and here we have not given any proper error. Here you have provided zero division error. Here always maybe you are not aware about the errors. Here you are giving index error, then this is taking care of that. If you do not know, then simply also without definition also you can go, then it will be capture the errors whatever is possible errors that will be captured. So then you can have value error, key error, index error, type error, zero division error, and all. File not found, multiple exception, multiple errors can be. Then catching and dredging exception. So it is a good practice if you are handling with the try and catch block, where we can handle the exceptions using try and accept. And dredging, use raise to manually trigger exception. Manually trigger exception in the sense, maybe always you are not sure or you want to print in your own way how you want. So let's take this. I think I should have the codes over the notepad. It is always copying some different characters, special characters. Okay, so this is coming to caught an exception. This is a custom error. Okay, so if you want to go for some custom errors and all, you can always go with this. Then we have advantage. What is the advantage if you are handling this? So while handling this, you can improve the code readability, and you can ensure program stability with its failures, errors, and all. You can handle that properly. Disadvantage can be because it is going to its complexity. Maybe for a single line you want to read a file. With a single line only you can read the file, but you are keeping try, catch, except some other, maybe finally, then you are adding some complexity to the code, and misuse can lead to hidden bugs. Again, unnecessarily, if you are going for the handling, then of course that can lead to some hidden bugs as well. Maybe something else should come, some other kind of errors can be there, but you are handling something else, or maybe you are handling proper only, but that is leading that some genuine case is going to be hidden in uh, with that exception whatever you have handled. So that things also can be sometimes. So we should always avoid using excessive try catch and all unnecessarily. Whatever is required, just go with that only, but use that. Using is the best thing. We should use try catch exceptions and all. We should handle the exceptions, but we should avoid adding the complexity and too much unnecessarily handling print loggers and all. Anyways, loggers are always good if you have the limitation. Otherwise, that will be again a overburden to your code. Then that is about exception handling and errors. If you are doing any of the POC, anyways, I will use one. I will share one use case to do this, where you can bind all the things. You can do that. So try to handle that errors, exceptions, and all genuinely. Then this is the final topic we are going to discuss. This is about Python UDFs and most useful libraries. Okay, in the Python, because you are going to work with different things. You are going to work with the data frame, files, some list, some different kind of data with some different kind of requirement. You can have a simple requirement. You can have some visualization related. You can have some machine learning, many more. Okay. So accordingly, we have lots of libraries. Here I'm going to talk about a few, but there is no limit. There is not limited to this one. This is just an example I have captured, but there will be multiple. If you are whenever you are going to work with the real time, you will be getting that. So very first, I'm going to talk about this Python UDF and most useful libraries, where we will be exploring all the things. And then we have here I'm going to discuss about understanding the user defined function. Then I have captured a related to data engineering. Okay, but again I'm saying there is no limit. This is not limited to uh, you. Maybe you can get some other one in your use case in your program. But pandas, that is something mostly in most of the projects you will be getting use of it. So pandas, then NumPy, then you have PySpark. PySpark because this is we are going to work with the Spark. Then of course with Python. PySpark is nothing but Spark plus Python. Using Python language we are working with that. Then SQL, that we are going to work with our databases. Then Metapolyp, then Seaborn, then Sky, Dask, Airflow, beautiful soap and all. Here, then a user defined function. So these functions created by users to extend Python's capabilities, where we can get reusability, reusable and modular code, simplifies complex tasks, enhance readability. We can define like this definition, your function name, you can have the n number of parameters, and then this is the doc string. Doc string is simply a print statement, means you want to say something about the function. That's what is this. Okay, like that. Then you can have your function logic and you can result finally whatever you want to return. So this is your UDF. So here, let's say for UDF, I am going to the sample code here. Let me delete all these things or let me comment it. Then I am saying simply def, let's say greet user, simple one. I want to make a function for the greetings. Then I'm saying name. And here doc string, you know, right? You want to say something. Let's say I'm saying this is a function to greet users. And then I can say, okay, already it has captured parameter name. So name of the user, you can define name of the user. So this will be making readability of the code. Anyone can understand your code completely. Return whatever you want to return, you can maintain. If not, then let me delete it. I am not going to maintain about that. Okay. Then here I am saying return. I'm not going to implement any logic. Simply I'm saying return and hello name. This is the parameter. Name. Welcome to this session. Welcome to this session. Okay. That's it. This is my function which is returning this. Now I am calling this. So let's say print great user and name. Let's say I'm saying Ram. Let's print it. Hello Ram, welcome to this session, right? So this is the UDF, and for the UDF we can say this is a user defined function that is a reusable block of the code that can be defined to perform a specific task, and we can use it whenever needed by calling the function with appropriate args. Whatever args I need, I can. This is a simple example, okay? Then if we are talking about the project wise, then you can have multiple use cases for this. Let's say next we are going to talk about the pandas. So inside pandas also you can go with this because this UDF is going to work all the functions and all we are going to work all together. If you talk about pandas, then pandas is a powerful library. Let me go here. Pandas. So here you can say purpose-wise data manipulation and analysis, where it works with data frames for structured data, reading and writing like CSV, Excel, SQL, and data cleaning and doing the transformation. We can use it. So Pandas is a powerful Python library for data manipulation and analysis, and it provides data structures like series for 1D data and data frame. Data frame means 2D data, and to handle and analyze structured data very efficiently. Pandas is widely used in data engineering project, I can say, for data analysis. And whenever you are working, whenever you have opportunity to work with machine learning and all, there also pandas will be widely used. Mostly we use it for data cleaning, where we can use for handling missing data, duplicate data, inconsistent formation of the data. For data analysis, you can use for perform statistical analysis and the data aggregation. For the data manipulation, you can use for like filtering, sorting, doing the grouping, merge the data, reshape the data set with some different structure because whatever structure is available, maybe you are not okay with that. Then integration. Again, this is having a good thing that it works seamlessly with other libraries like you have NumPy, you have Matplotlib, and yeah, this one Matplotlib and Scikit-learn and all. So you can do the integration. You can work with that. For example, let's say you have this library. Let me just copy it and will print here. So pandas is not yet installed. I need to install this. Okay. Anyways, I have already copied here. So let me go through it. Okay, so it is not yet installed. I will let it get installed. Okay, it is already getting installed here. Here, if you see name, there is some name, then there is some age and some data. Here, what we are trying to do with pandas, we are trying to convert that with the data frame. Then our data will get converted in a structure format, like tabular format, row and column wise. Whenever we are working with the data engineering project, then you, if you are having the Spark, you can create a Spark data frame and you can do whatever you want to do. But let's suppose that you are not looking for a Spark and without a Spark, you want to perform all the activities, similar kind of transformations and all. Then simply you can skip from Spark to Pandas and you can work in the same way. You can convert your data to the tabular format and you can do similar transformations of aggregations, groupings, whatever you want to. Okay. So this is done. Let me run this one. Then we will go one by one. Okay, this is installed. Let me run it. If you see, this got name, this is the column name, age, and this is the data, row wise, row and column you are getting. This is the indexing. This is the by default in Pandas data frame. You will be getting, you can say, means we are not defining any primary key or any row number, right? So this will be kind of row number, which is coming automatically. We are not going to define it. If you, in your case, if you want to remove it, you can have, you have the options, either you are want to go with it or not, but internally this will be defined with the data, it will be associated. So this is about the uh, Pandas one, where you can do the grouping, you can do the aggregation. Here I have did it like a fill missing values in the age and salary with column mean. Here I have none value, right? None means null. So if you want to do that, then we have fill NA. Okay, where you want to in place something, some mean value. So you can do that. Means some data manipulation, simply you can say. And if I run this, it again it will fail. I know. But before failing it will be running. So this is getting this Amit and some salary. So here it is NAN, that is by default if you are not handling this. And then data frame after filling missing value, anyway this is failing, okay, because of some errors. Okay, but here if you see, this was Amit, which has 25, 30, 27 and 28. Okay, so this has been filled up, right? 5000, yeah, with the mean value. So we can do some data manipulation. Then we have a second, another one is the NumPy. Pandas, then Pandas example. Okay, so here simply filter DF. Then if you want to DF, then like this Spark data frame, here also we can apply the filtering and all. Then you have this one. So purpose of this is numerical computing and multidimensional arrays. You have mathematical operations, you have integration with some other libraries, then you can go with this library. And for this, like Pandas, you have to import this. And this, if you are doing this, then it will ask for installation. In my system also, most probably it is not installed. We are here, let me copy it. Okay, it seems this is available, this is done. So you can say 2, 4, 6, 8. Okay, because we are saying multiply. So 1 into 2, 2, 2 into 2, 4. And if I do this 5, then it will be coming with additional 10. This one. Okay, so like that for any operations related to number, numerical computing, we can go with this library, and this is really very much useful. Like Pandas is having some data manipulation, aggregation, filtering and all requirement with the numbering and all. We use this also very much in the real-time projects. Then here we have some examples. Anyway, I will share the exercise, a deep exercise with this. Okay, this PySpark, we will skip this for now because whenever we are going to start the session tomorrow with PySpark, we will be discussing about this. So purpose for the PySpark is distributed data processing, where we are going to handle large data sets because it works in a distributed model. If you are working with Pandas, Pandas is also converting the data into data frame, tabular format, but that is not working like PySpark. Completely resource computation, distribution, management, and how it is working with the distributed model, everything is completely changed. So that is not good for the large data sets. If you have large data set, then PySpark is a better option. Okay, so uh, here purpose is mostly distributed data processing, then handling large data sets, integrates with Hadoop, and supporting SQL-like queries. And here we have to go with the from PySpark. We have to import whatever we want. So we will. I'm going to skip this. We will see this tomorrow in our PySpark session. Then we have SQL alchemy. This is for database interaction because maybe you are not working with PySpark, but in Pandas only you want to do some database related in activity. You are going to read and write from database. You want to do some transformation with that. Then you can use this. So we can go for the relation mapping, then easy query construction. We can support it is supporting multiple databases where we can go with this from import this statement, and we can have the create engine, and then we can provide all the credentials details like your username, password, your URL. Then we can connect with that engine, and we can read, write to, and whatever you want to do we can do with this. Then we have uh, next one is visualization libraries where you have matplotlib, okay, where the main is basic plottings where you can go with anyway. This is not installed in my system. This is going to be fail, but let me try if that is working. When you work, then you can install one by one all the things, all the libraries, and then this will be working for you. I was just capturing the small things, so I have not yet installed in my system. So if we have that kind of requirement, you can go with this. You can utilize this, and even you can do one small POC with this for your better understanding. We have Seaboard, where purpose is theoretical data visualization. If you want to do some kind of use case like this, then you can go with this library. And then you have like machine learning and all. If you have some requirement with machine learning, then you can go with this library, okay. And uh, you can have your machine learning models for pre-processing tools, classification, regression, clustering. And by importing from this sklearn, you can import and you can build up your models whatever you want to build. Then you have task. This is for parallel computing for the large data sets where you can handle out of memory computation, integration with the pandas and NumPy, and then you can again similarly you can do the import like this, and you can work. But if in case you have large files and all where you want to handle in a more better way, you can go with this. And then you have airflow. Again, airflow, I just mentioned for the example because in the real time right now, you may see most of the companies are having ask if you know airflow, right? Airflow is a kind of scheduler only workflow where you can Python based, you with like the Python code only, you can have your flow and kind of ETL, uh, like you can say bronze, silver, and gold layer, and you can schedule the jobs, and you can have the triggers how you want to either with the dependency or independently. So workflow orchestration, so this is again a library in the Python available which you can use for your workflow orchestration where you can schedule and monitor the workflows. And this is Python based attacks. So if you are a developer and you are good in the coding, then this is really good to maintain. We have lots of schedulers and all, right? But everyone is having some different things, either with some scripting or maybe from the GUI you are going to manage. But here, this is with the Python code. And if you are good with the Python, then this is really good to maintain and all. And the next time, whenever you are pushing the next version of the code, if you want some changes in the airflow, you can have that line changes in your airflow code base also. That will
Yes,
be working.
we are currently using Airflow in our project. Yeah.
All right. Yes. And then airflow and then beautiful. So this is for web scraping. if you have a requirement with HTML and XMLs and all, where you can extract some specific data. You can, if you are working with some financial data and all, I have seen this requirement in one of the banking project, but this is not limited to, again, because everyone is having some different kind of data and requirement where you can have. So if anytime you have some requirement with the web scraping, then where you want to parse this XML, HTML data and all, is extracting some specific data, then you can go with this. You can import this from BS4 import beautiful soap, and you can do this. You can to use the parser and you can extract the data, extract the specific data from the specific node you want to. So these are some libraries, but as I already said, there is no limitation. This is just some numbers, and there are 100 plus, I can say 100 to 100 plus. So multiples are there, and as per your project, as per the requirement, these will be keep on changing. But these are something which will be crossing your path. Most of the time, you will be using this. You are going to use it. But again, some new can come. You have to learn that. You have to go with that. Just do exploration and do that, because learning is a part of software engineers, right? Otherwise, we can't survive. This is the simple line. So this is something about the Python, and anyone has any question? Whatever exercises I shared already, you people have done that? Anyone?
Yes, Anamika. Mostly.
Need to have done.
Okay. No issue. For tomorrow, exercise can be a bit lengthy. Okay. You can do either in 1 day, 2 day, 3 day, doesn't matter. But try to do that. Anyways, I will try to make that small, but I will try to cover almost topics. I will create one exercise and I will share and do that. And by tomorrow, we are going to start PySpark. Okay. So
So
let's
how many days PySpark will take? So it's a big concept, big topic, I think.
all right. The PySpark will be taking a good number of days.
Yeah.
I can't say the exact count, but that is going to take time because we will having
So I
some
think
pipelines also,
from
right?
data engineering perspective, all the interview I have faced, mostly they don't go into all this. Mostly they ask scripting questions only. Some questions, some company may ask on pandas, but most of them just ask string, dictionary, those kind of
So
operations. Two, three
Pandas is
questions.
related to Python, right?
Yes.
That is not your PySpark. Pandas
Yeah, no,
can come as a
from Python.
question.
I am saying from
Ah,
Python, they only
yes.
ask from basically basic string operations or dictionary operations, how to handle those, word count, those kind of things, duplicate
Hmm,
removal.
hmm.
Uh, Loops, they usually don't ask, I think, for experience.
Uh, you can't say. One
Yeah,
year
yeah,
back,
depends upon.
I had given one interview. Okay, that was for a very good company, product-based company. And question was simply, do you know loops? This was the simple question. I said yes. Then question comes, explain about do while. We have do while, right? For
Yes,
loop. And how you can means stop the loop, means kind of break, right?
break.
When we do the break. So they will not be asking with the simple exact keyword because they want to confuse you, correct? They
Yeah.
want to know either you know or not.
The
So simply,
fundamentals, yeah.
so simply their question was either I know the loops, then explain the type of loops and give example. So I simply write here in the POC also in the class. I am not writing the exact code and all, right. Simply I'm giving one liner. So like that only I defined one line. Okay, this is the for and this is how I am breaking the code and all, and it worked. That was fine for everyone. There was no issue.
Got it. Yeah. So it depends upon. Sometimes
It
they may
depends.
come.
It
Yeah. Yeah.
depends. Yes, we can't say what will be there, but only thing is you have to be clear from your side. See, the thing is, if you are not really practicing with the deep and all, that is okay. But if you are doing a small POCs also, at least you will be having some confidence. You will be having some understanding, and the interview, if you are not giving the deep details and all, if you are good to give the skeleton code also, then people can understand. Okay, you are having good understanding, and that will be working for you.
Yes, correct.
Because nowadays all do Google, right? We are
Yes,
too
if
good
they
in copy paste. Everyone.
if,
So if someone will ask us to do this complex codes and all, immediately maybe if we are good in coding, of course we can. But most of the time, maybe we are not good to do, and we can take some help from some other resources. There can be the condition, but you can take help from the resources only if you know the concept. Means we say no, cheating also needs the sense. Otherwise, how you will be, right?
yes,
So
yes.
you have to know the concept. Without knowing the concept, you can't do anything. So just go through this, and in interview you have to take care of that. So at least a high level you should know, so you can explain at least a skeleton code. Okay, fine then. I will share the exercise for today and for tomorrow. Means make sure that your system is good with the Spark setting. Install and do the path setup and all environment variable. So we can start with that, and let's meet tomorrow then.
Also, one more thing, Navi, can we use Databricks Community Edition to practice also?
Of course you can.
Yeah.
Only integration you will not be able to do. Let's say you want to read the data from database. You want to read the data from Kafka. Then your community edition will not work for the integration.
Yeah.
Otherwise, all the things you can.
Yeah.
Okay, fine. Have a good day. Bye.
Thank you.